Hi Candles, welcome to Candela Learnings. It's me Navya Prajit, your maths tutor. In previous session, we have learned the geometrical meaning of zeros of linear polynomial and quadratic polynomial. For any linear polynomial, the graph will be a straight line and it will have exactly one zero. And for quadratic polynomial, the graph will be in the shape of a parabola and it will have at most two zeros. And here we are going to check the pattern for a cubic polynomial. Let's take the example x cube minus 4x. First, let's put some random values for x, which is minus 1, 0, 1, 2, 3. And we are going to check the corresponding value of y here. So, y will be equal to minus 1 cube minus 4 into minus 1, which is equal to minus 1 cube is again minus 1. So, 4 into minus 1 is minus 4. So, minus 4, which is plus 4. So, it becomes 3. Then if x is 0, y becomes 0 cube minus 4 into 0, which is again 0. And if x is 1, then the corresponding value of y will be 1 cube minus 4, which is minus 3. Then if x is 2, y becomes 2 cube 8 minus 4 into 2, which is 0. And if x is 3, then y becomes 3 cube, that is 27 minus 4 into 3, which is 12. It becomes 15. And we are going to mark these points here. So it is minus 1 comma 3, then 0 comma 0, then 1 comma minus 3, 2 comma 0 and 3 comma 15. And here let's join these points. And you can see a curve, and this graph cuts x-axis at 3 points, which means there are exactly 3 zeros. And you can see the points, they are minus 2 comma 0, 0 comma 0 and 2 comma 0. And we know that the 0, which means you can see 3 points and the x-coordinate of that point is the 0 of this polynomial. Here it is minus 2, 0 and 2. We got 3 zeros. They are the x-coordinate of the points where the graph cuts x-axis. So in this case it is minus 2, 0 and 2. And let's check for another example. Y equal to x cube. If x is minus 1, y becomes minus 1 itself. If x is 0, y equal to 0 itself. If x is 1, y is 1. If x is 2, then y becomes 2 cube, which is 8. And let's mark these points. Minus 1 comma minus 1, 0 0, 1 comma 1 and 2 comma 8. And let's join these points. We are getting a different curve, right? It is not similar to the first graph. So we can tell that there is no fixed shape for a cubic polynomial. And this graph cuts x-axis at exactly one point, which means there is only one zero for this polynomial. And the point is 0 0. And the x-coordinate of that point is 0, which means that is the 0 of this polynomial. And let's check one more example so that y equal to x cube minus x square. I'll show you the graph. You can see a different curve here. And this graph cuts x-axis at exactly 2 points, which is 0 0 and 1 0. And the x-coordinate of that point, which is 0 and 1, those are the zeros of this polynomial. So we have came through 3 graphs and it does not have a fixed shape, which means for any cubic polynomial there is no fixed shape, and for a cubic polynomial it will have at most 3 zeros, either 0 zeros or 1 0 or 2 zeros or 3 zeros, but not more than that. It will have at most 3 zeros. And now I'll show you some graphs and I want you to answer how many zeros are there in each cases. In the first case, you can see the graph cuts x-axis at exactly one point, which means there is only one zero. Then in the second case, can you tell how many zeros are there? The graph cuts x-axis at 2 points, which means there are 2 zeros. And from the figure you can tell that it is a quadratic polynomial. And it is opened downwards like a closed vessel, which means a is negative. The coefficient of x square is negative in this case. And in the third graph, you can see that the graph cuts x-axis at 3 points, which means there are 3 zeros. This is how we'll be finding the number of zeros in each cases, just by looking at the points where the graph cuts x-axis. The x-coordinate of that point is the 0. And let's take the fourth graph. It is a straight line, which means it is a linear polynomial. And it cuts x-axis at 1 point, which means there is 1 0. Then the fifth graph, it is also a parabola which touches x-axis at 1 point, which means there is 1 0. And the last figure, you can see 1, 2, 3, 4. There are 4 points which cuts x-axis, which means there are 4 zeros for this polynomial. And now, we are going to enter into the topic division algorithm. First, we will be learning factor theorem. If a is a zero of the polynomial p of x, then x minus a divides p of x, or x minus a is a factor of p of x. For example, if 2 is a factor of a polynomial, then x minus 2 is a factor which divides this polynomial. With this theorem, we will be doing one problem. Find all the zeros of 2x cube plus x square minus 6x minus 3 if 2 of its zeros are root 3 and minus root 3. I told you if 2 is a 0, then x minus 2 is a factor which divides that polynomial. Similarly, if root 3 is a 0, then x minus root 3 is one of the factor. And minus root 3 is another 0, which means x minus root 3 is another factor, which means x plus root 3. And these two are factors of this polynomial. And a plus b into a minus b equal to a square minus b square. So, it becomes x square minus root 3 square, which is x square minus 3. And we will be dividing this polynomial with this term, x square minus 3. Polynomial is 2x cube plus x square minus 6x minus 3. Right? Yeah. And this is the dividend. And the divisor, which is x square minus 3. We will be writing it here. And using long division method, we are going to solve this. 2x cube, first step is dividing 2x cube with this term, x square. And it is equal to 2x. And we will be writing it as the first term of quotient. And the next step is multiplying this 2x with this term. 2x into x square, which is 2x cube. Then 2x into minus 3, which is minus 6x. Then we are going to subtract it. 2x cube minus 2x cube is 0. Then x square minus 0. Then minus 6x minus 6x, which is 0 again. X square, then minus 3 is left. We will be writing it down. Then the next step is again dividing this term with this term, which is x square by x square, which is equal to 1. So, we will be writing it here, plus 1. Then the next step is multiplying this 1 with these terms. So, 1 into x square, which is again x square. Then 1 into minus 3, it is minus 3. And subtracting it, we get 0 as the remainder. So, to check this step, to check whether our step is correct, we will be multiplying divisor into quotient plus remainder. We should get the result as dividend. We will be checking it now. So, the divisor, which is x square minus 3, then the quotient, which is 2x plus 1 plus remainder, which is 0. So, we do not have to write it. We should get dividend, which is 2x cube plus x square minus 6x minus 3. X square into 2x, which is 2x cube. Then x square into 1, which is plus x square. Then minus 3, then x square into 1, which is plus x square. Then minus 3 into 2x, which is minus 6x. Minus 3 into 1, which is minus 3. Yeah, we got the dividend again, which means the steps are correct. So every time dividend equal to divisor into quotient plus remainder. If p of x and g of x are any two polynomials with g of x not equal to 0, then we can find polynomials q of x and r of x such that p of x equal to g of x into q of x plus r of x. And where r of x not equal to 0 or degree of r of x less than degree of g of x. And this result is known as the division algorithm. And we'll be doing some problems based on this. Divide 3x square minus x cube minus 3x plus 5 by x minus 1 minus x square and verify the division algorithm. We know that division algorithm is dividend equal to divisor into quotient plus remainder. For that we have to find quotient, right, using long division method. We know that this polynomial is not in the correct order. So we'll be rearranging it first based on the descending order of their degree. So first term will be x cube minus x cube, then plus 3x square minus 3x plus 5. This is the dividend. Then the divisor, that is also not in the correct order, so we'll be rearranging it. Minus x square plus x minus 1. And we are going to divide it. Minus x cube plus 3x square minus 3x plus 5, right? Yeah. Then we are dividing it with minus x square plus x minus 1. Minus x square plus x minus 1. And the first step, you know that we are going to divide minus x cube with minus x square. So minus x cube by minus x square, which is equal to x. And multiplying the first term of quotient with the first term of divisor, which is x into minus x square, that is minus x cube, then x into x, which is x square, then x into minus 1, which is minus x, and we are subtracting it. Minus x cube minus minus x cube, which is 0, then 3x square minus x square, which is 2x square, then minus 3x minus minus x, which is minus 3x plus x, which is minus 2x plus 5. And the next step is dividing 2x square with minus x square. So it becomes 2x square by minus x square, which is minus 2. So writing it as the second term of quotient. Then the step is multiplying minus 2 with this term. We get 2x square, then minus 2 into x, which is minus 2x. Then minus 2 into minus 1, which is plus 2. Then subtracting, we get 5 minus 2, only 3 is left, and that is the remainder here. And also we have to verify the division algorithm. For that, the divisor, which is minus x square plus x minus 1 into x minus 2 plus remainder, we should get dividend. We are checking it. Minus x square into x, which is minus x cube. Then minus x square into minus 2, which is 2x square. Then x into x, which is x square minus 2x, minus 1 into x, which is minus x, then minus 1 into minus 2, which is plus 2, then plus 3 is left, and it becomes minus x cube plus 3x square minus 3x plus 5. Yeah, we got the dividend. So divisor into quotient plus remainder, we should get dividend. So the division algorithm is verified here. And moving into the next question. If the zeros of a polynomial x cube minus 3x square plus x plus 1 are a minus b, a plus b, find a and b. So here we know that for a cubic polynomial in the form ax cube plus bx square plus cx plus d, when alpha, beta and gamma are the zeros of this polynomial, then taking sum of these zeros, which is alpha plus beta plus gamma, we should get minus b by a. Then taking alpha beta plus beta gamma plus gamma alpha, we should get c by a. Then taking the product of these zeros, we should get alpha beta gamma equal to minus d by a. And generally we can write the polynomial as x cube minus alpha plus beta plus gamma into x square plus alpha beta plus beta gamma plus alpha gamma into x minus alpha beta gamma. And comparing this with the polynomial given in the question, we can tell that alpha plus beta plus gamma here is minus 3. Sorry, minus of minus 3, which is plus 3. Then here alpha is a minus b, beta is a, then gamma is a plus b, and a plus a, which is 3a, minus b plus b is 0. 3a is equal to 3 and a becomes 1. So we have found out the value of a and we have to find the value of b. For that, this alpha beta gamma equal to, here alpha is a minus b, then beta is a, then gamma is a plus b. Here taking these two terms, it is in the form of a plus b into a minus b, which is equal to a square minus b square. A square minus b square into a, which is equal to a cube minus a b square, right? Yeah. And it becomes, we know that a cube is 1 minus b square, which is equal to, here product is equal to minus 1. So we get b square equal to 1 plus 1, 2, and b equal to plus or minus root 2. So a equal to 1 and b equal to plus or minus root 2. So we have found out the values for a and b using that alpha plus beta plus gamma equal to minus b by a, and alpha beta plus beta gamma plus gamma delta equal to c by a, and alpha beta gamma equal to minus d by a. So this question was based on the relation between zeros and coefficients of a cubic polynomial. Then I'll give you a super tip. A linear polynomial, you know that the graph is a straight line. Yeah. Then for quadratic polynomial, it is in the shape of a parabola, U-shaped curve, which is called a parabola. Then if you are waiting for the tip for cubic polynomial, I'm sorry, we don't have, because for a cubic polynomial, it does not have a fixed shape. So for a linear polynomial, it is a straight line, and for a quadratic polynomial, it is a U-shaped curve, which is called a parabola. And for a cubic polynomial, there is no fixed shape. And in this session, we have learnt the geometrical meaning of zeros of a cubic polynomial. And there are at most 3 zeros for a cubic polynomial. And in the next session, we'll be doing few questions based on this. Now it's time for you to relax. Thank you.